Welcome back to this channel for practice problems for actuarial examinations. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. And I offer online seminars and manuals for exams P, FM, MLC, and MFE at the URLs that I'm giving you here. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to our program, go to smarturl.it/help-ISU-actuary. Here's a problem for today. This is Spring 2017 exam, written answer section problem number 4. You are designing and pricing a single premium whole life annuity with benefits of $10,000 payable annually on Kevin, age 35. You are given that the first annuity payment is at age 65. Initial expenses of 4% of premium. Maintenance expenses of $40 per year. Maintenance expenses are payable at the beginning of each year, including the first. Additional administrative expenses of $50 are incurred with each benefit payment. Mortality follows the illustrative life table, and the interest rate is 6%, which is the interest rate used in the illustrative life table. 0L denotes the random variable for the present value of the loss at issue. Calculate the single gross premium using the equivalence principle, and the gross premium, of course, means premium accounting for benefits and expenses. Show that the smallest single gross premium such that the probability that the loss at issue is greater than 5,000 is less than 0.10 is 21,000 to the nearest 1,000. You should calculate the premium to the nearest 10. Your supervisor suggests that you change the design of the annuity to refund the single gross premium with interest at 6% per year if Kevin dies before age 65. The refund would be paid at the end of the year of death. For Part C, calculate the revised single gross premium using the equivalence principle. For Part D, show that the revised smallest single gross premium such that the probability of the loss at issue is being greater than 5,000 is less than 0.10 is the same as the premium calculated in Part B. And the final second part of D is explain why in this case the premium does not change. So let us write G for the gross premium. Using the equivalence principle, we write this equation that the premium pays for the initial expense of 4% of premium, for the expenses of $50 per year, plus the annuity benefit payable 30 years from now of $10,000, as long as the person is alive, plus the expenses of $50 per year, which are also payable then. Therefore, of course, we know that the interest rate is the same, the problem is the same as in the illustrative life table. We can just solve this for G. We move everything with G to one side, and that just becomes 0.96G equals the right-hand side. And then we divide the right-hand side by 0.96, and we have what G is. We just need to figure it out based on the data that we have. So there is no pure endowment for 30 years in the table, but there is data on pure endowments for 20 and for 10 years. And we simply write the 30-year endowment as a product of 20-year endowment times 10-year endowment. You could actually go from 35 to 45 and then from 45 to 65 instead of going from 35 to 55 and then from 55 to 65. It's the same thing, but you need to split the 30-year endowment into a product of 20-year endowment times 10-year endowment. Or if you really want to make it harder on yourself, you can split it into a product of 3 10-year endowments, but don't do that. it's a waste of effort. You can just do what I showed you here. And then we calculate those values there. So this 58.35, that turns out to be 769.63 approximately, and the rest turns out to be approximately 13,849.5407. And the answer that we get is 15,228.3028. Well, because this is an annuity policy, the loss at issue for a given premium is an increasing function of the future lifetime. The longer the person lives, the more expensive this thing gets for the insurance company. We need to find the smallest integer k such that the probability that the future curtailed lifespan is greater than or equal to k is more than 0.1, but the probability that the future curtailed lifespan is greater than or equal to k plus 1 is less than or equal to 0.1. Of course, this corresponds roughly, not exactly because k is an integer, but what we're looking for is roughly 90th percentile of k35. Well, let's consult t35, the corresponding continuous length of lifetime. The 90th percentile for t35 is the number t.90, such that L at 35 plus t.90 is 0.1 of L35. So survival beyond that time has only a probability of 0.10. That's why it's a 90th percentile. That's the same as saying that t.90 p35 is 0.1. From the data in the illustrative life table, we can determine that 55 p35 is 0.112, and you do this by simply taking the ratio of population sizes for age 90 and age 35. The ratio of the two will be 0.112, and the ratio of the population size at age 91 to the one at 35 is 0.0911. This means that the 90th percentile lies between 55 and 56, and the curtailed lifespan then is 55, and k plus 1 is 56. So for the loss to have probability less than 0.1 of being greater than 5,000, the premium must be big enough for the loss to be equal to 5,000 if 35 survives to age 90, which is a term of 56 years for the expense annuity due, and a term of 26 years for the deferred annuity due. Please remember also that the deferred annuity due, it includes its own portion for expenses of 50. But there is the regular expense annuity, and then there is this additional one that shows up when the benefits are paid. If 35-year-old dies between ages 90 and 91, the loss at issue is all the expenses and benefits minus the premium, and that ends up being approximately 24,967.70 minus 0.96 G. To assure that this loss is no greater than 5,000 when K35 equals 55, we set G such that the difference that we calculated equals 5,000, and this results in G equal to 20,800. The expected present value of the return of premium benefit, if the premium is H, I'm using different notation because it's potentially different premium, is, well, it's that H with the payment being made at the end of the year of death for the first 30 years, and the payment then increasing, but at the same time we discounted for the calculation, and increases and discounting cancel out. So this ends up being simply H times the probability of dying during the first 30 years, and we can calculate it from the data in the illustrative life table. So when we plug in those numbers, L65 or L35, That's the probability of survival over those 30 years, and 1 minus it is the probability of dying. We end up with 0.200271918. So for a premium age, this is the cost of the return of premium feature as prescribed in this problem. So the new equation of value for the premium, including the special return of premium feature, is called G star, implied by the equivalence principle, becomes G star. It pays for 0.04 G star plus this new 0.2 roughly of G star plus previously calculated when premium G was being calculated, all the other unrelated to premium 2 parts really. And then from that, G star is 14,619.1707 divided by 1 minus 0.04 minus that roughly 0.20, and that ends up being 19,242.6356. Suppose that the premium is G equal to 20,800 as it was in Part B. Then the loss from death before age 65 is at most 0.04. This is the expenses minus the premium. It's 1562. This means that it is not possible for the loss at issue to exceed 5,000 when death before age 65 occurs. After age 65, the return of premium feature no longer applies, so the calculation of the smallest single gross premium such that the probability that loss is greater than 5,000 is less than 0.10 is the same as it was in Part B exactly. In particular, when K35 is greater than or equal to 30, we have the worst 10% of losses when K35 is greater than 55, exactly as it was in Part B, and so the smallest single gross premium such that the probability that loss exceeds 5,000 with probability of no more than 0.10, or less than 0.10 actually, is exactly the same as before, 20,800. And the premium is the same because it is determined by the worst 10% of outcomes for the loss at issue random variable, and the return of premium benefit does not change the set of worst case losses, and therefore it does not affect the quantile premium. The worst case losses happen in the annuity tail. Please remember this is copyrighted material. The solution is mine, but the problem itself belongs to the Society of Actuaries and was reproduced with permission. Good luck in your studies and good luck on the test.